All right, let's get right into it. We've all seen it happen, right? That little bit of computer magic where detail just seems to appear out of nowhere. But how does that really work? How can an AI literally invent information that wasn't there to begin with? That's exactly what we're going to break down.
You know the transformation I'm talking about. You've got this low-resolution, pixelated mess, you run it through a tool, and suddenly it's sharp, it's detailed, it's actually usable. It feels like you found a cheat code for reality. So what is actually going on under the hood when this blurry image gets such a major glow-up?
So, the first thing to get your head around is that AI upscaling isn't really enhancing in the old-school sense. It's all about prediction. It's not finding hidden detail, it's creating brand new detail based on a mountain of data it's already seen. The AI is making an incredibly sophisticated, educated guess about what the high-resolution version of that image should have looked like.
And this is really the fundamental difference. Traditional methods, the stuff that's been in Photoshop for ages, they just stretch and blur the pixels you already have. It's like taking a small photo and just pulling it at the corners. It gets bigger, yeah, but it also gets way fuzzier. AI is totally different. It looks at the patterns in those pixels and generates entirely new ones to fill in the gap.
I love this quote because it just nails the concept. Controlled hallucination. The AI has been trained on millions, maybe billions of images, so when it sees a blurry pattern, it sort of hallucinates the most probable detail that belongs there. It's seen enough faces to guess at eyelashes, enough landscapes to guess at blades of grass, and enough buildings to guess at the texture of brick. So how does it learn to make such good guesses? Well, the training process is a surprisingly simple idea. First, you feed the AI a massive library of beautiful, high-quality images. We'll call that the truth. Then, you systematically make them all low quality. The AI's job is to take that crunchy, low-res image and try to reconstruct the original. It compares its guess to the truth, sees where it went wrong, and adjusts its strategy. You do that millions of times, and pretty soon it starts to learn the visual grammar of our world. Okay, so that's the basic idea. But not all AI upscalers are built the same. Let's pop the hood and look at the different kinds of engines that power these tools. Each one has its own personality with different strengths and weaknesses.
First up, you've got your CNNs, or convolutional neural networks. Think of these as the reliable workhorse, the Ford F-150 of AI upscaling. They're really good at recognizing features like edges and textures. The results you get are stable, they're predictable. The downside? If you crank the settings up too high, you can get that slightly artificial, over-processed look.
Then you have the GANs, Generative Adversarial Networks. Now these are the flashy artists. A GAN is actually two AIs locked in a battle. One AI, the generator, creates the upscaled image. The other AI, the discriminator, tries to tell if the image is fake. This constant competition forces the generator to get incredibly good at creating sharp, convincing details. The trade-off, sometimes it gets a little too creative and just invents stuff that wasn't there, like famously adding an extra eyebrow to a portrait. It's definitely high risk, high reward.
And the newest kid on the block is diffusion. These are the creative wildcards. They work by taking an image, adding digital noise until it's just a mess of static, and then training an AI to perfectly reverse that process, step by step. By learning how to remove the noise, the model becomes incredible at constructing plausible images from scratch. The danger here is that they can sometimes drift a little too far from the source, kind of reimagining your photo instead of just upscaling.
So, how does this all translate to the actual software you might use? Well, this gives you a pretty good idea. You've got tools like Topaz, which are amazing all-rounders that often mix and match different models depending on what's in the picture. Then you have Adobe's features in Photoshop, which are a bit more conservative. They're really focused on clean, believable results for photographers. And then there are open-source models like Real ESR GAN, which are just fantastic at generating rich, sometimes intense textures. The right tool really just depends on what you're trying to do.
Knowing the tools is one thing, but how do you judge the results? It's time to train your own eyes, to develop a bit of a critic's eye and learn to spot the telltale signs that an AI has been doing the heavy lifting. And trust me, once you see these, you can't unsee them.
Here are the biggest red flags to watch for. First, that waxy, unnaturally smooth skin on faces. Second, those glowing halos you see around sharp edges. Third, textures that look a little too perfect, like someone copy-pasted the same patch of bricks over and over. Fourth, text that gets mangled into a mess of almost letters. And if you're working with video, watch out for that awful shimmering or flickering, where details seem to crawl from one frame to the next. Which brings us to a really important rule of thumb. The best upscaling isn't the one that screams, "Look at how sharp I am." The best upscaling is the one you barely even notice. It should just make the image look like it was taken with a much better camera in the first place. That's the goal. Okay, so you know what to look for. Now let's talk about how to actually fix those problems. Taking control of the settings is really what separates a great result from a plasticky, artificially looking mess. Think of this as your quick emergency cheat sheet. If faces start looking like porcelain dolls, you've probably pushed the noise reduction and sharpening way too far. Just dial them back. If the texture on a sweater or a wall looks weirdly intense, find a detail enhancement slider and lower it. And if you see those glowing halos, sharpening is almost always the bad guy. The golden rule is to start subtle. You can always add a little more later.
And you have to remember this. I love this line. Don't upscale 8x just because you can. Going past a 4x upscale is like asking the model to write fan fiction about your pixels. It's not just guessing anymore. It's making up entire stories about what might have been there. A good, clean 2x or 4x is usually the sweet spot for believability.
But that whole idea of an AI writing fan fiction about your image, it naturally brings us to a really crucial conversation. When an AI can generate plausible new details out of thin air, we have to start thinking seriously about truth, lies, and the pixels in between.
And this slide draws a really critical line in the sand. On one side, you have restoration, which is about trying to recover information that was actually there but got lost or degraded. On the other side, you have enhancement, which is about adding brand new information that was never there to begin with. AI upscaling, while it feels like restoration, is almost always a form of enhancement.
And that leads us to what is probably the most important rule of all. For your vacation photos, your old family pictures, go nuts, have fun. But if an image is being used where the truth really matters, in journalism, as legal evidence, for a medical diagnosis, you absolutely cannot treat the AI-generated details as fact. They are illustrative, a plausible guess, but they are not definitive proof. You have to disclose. So, let's do a super quick recap. 1. AI predicts plausible detail. It doesn't restore reality. 2. Different models, like the reliable CNN or the artsy GAN, give you very different trade-offs. 3. Train your eye to spot those classic AI artifacts like waxy skin and weird textures. And 4. Most importantly, always disclose that you've used AI when the truth and fidelity of the image are critical. And this is the big question I want to leave you with. As these tools get better and become a part of our everyday lives, our whole concept of photographic evidence is going to shift. When plausible becomes the new standard for an image, what happens to the idea of a photograph as proof? It's something we're all going to have to think about.